The objective of this experiment is to obtain energy from unusual materials such as fruits and to explain why.
To do the first activity, we need materials such as copper and zinc wires, 4 lemons, 1 LED light, 1 voltage meter, and 1 cell phone to record all the videos. First, we have to insert some copper and zinc inside of the lemons without touching each other.
We have 2 lemons and we have to connect the part that is copper with a clamp to the part that is zinc, and we do the same thing with the zinc to another lemon that has copper, and we repeat this until we have a circuit without closing the circuit.
Now we are connecting the cables.
In the last part of the experiment, we just have to connect the cables to the poles, and let's see the voltage of these experiments. Oh my god, it's so powerful.
The acid inside the lemons, being the electrolyte, gives the lemon the ability to conduct electricity. After connecting the LED light with the LED wires, the electricity produced was able to pass through the lemons, thus turning the LED light on.
The Pompey's team!
The kind of energy that food has is chemical energy.
Plants can transfer energy because they have citric acid, which is turned into an electrolyte that is the one that can transfer the energy to other places.
They function as electrodes which help the electricity pass from one lemon to another.
Food contains chemical energy that is used to transform it into electricity. Also, both need 2 different kinds of metal with the objective to work correctly and act as electrodes. And finally, they would need conductors. Electromagnetism is a force related to this experiment because it works with the number of electrons in the copper and the zinc. In addition to this, all electric currents are surrounded by a force called magnetic field. In conclusion, we were able to see that we can use food to convert its energy into electricity using simple materials and methods. Also, we could see that it is possible to relate this with one of the 4 fundamental forces, that is electromagnetism.
The purpose of this experiment is to use probability in different cases, such as tosses, and relate them with the 4 fundamental forces.
20 dices like these ones. For the experiment regarding the probability of the coin landing in tails or heads, we had to take the 20 coins and toss them. If the coin landed in heads, we had to take them out, since it meant it decayed. Whenever the coin landed in tails, it meant it hadn't decayed. Therefore, we had to keep tossing the remaining coins until we had no coins left, or we had tossed them 15 times. For the experiment regarding the probability of the dice landed in 6, we had to take the 20 dice and toss them. If the dice landed in a number other than 6, we had to take them out since it meant it decayed. Whenever the dice landed in 6, it meant the item wasn't stable. Therefore, we had to keep tossing the remaining dice until we had no dice left, or we had tossed them 15 times.
Our results were that with the coins we had to toss them 5 times to all of them to decay, and in the other hand, when we tossed the dice, they all decayed faster. They decayed in three rows. The time it takes for a substance to reach its half of its life, or to decay the half of it itself. The possibilities that a coin will land on tail or heads is a 50-50 chance.
There is a 16.6% of probability that one dice will land 6 side up and an 83% that it won't.
The half-life of a radioactive substance is the amount of time it takes to decay half of its atoms. Here, with the dices and coins, we saw how little by little the parts of the substances were decaying, which was whenever the dice landed on another number that wasn't 6, or when the coin landed on heads.
When comparing the theoretical graph with the real ones, we notice that with coinimium the information is similar. However, it had slight variations. On the other hand, Dicenium has a similar trend related to its theoretical information.
Relates with the weak force. This is because the term half-life refers to the time it takes to decay the half of a substance, which is related to a weak
This
force.
activity helped us to understand what the 4 fundamental forces are and what half-life is, by connecting it with something we already knew, which is the probability.